Okay, to find the end behavior, you're going to look at two things. You're going to look at whether or not this is negative or positive. This is negative. And then whatever the degree is of the leading coefficient, this is odd. So negative and odd means that it's going to be pointing up and then falling. So as x goes to negative infinity, it's going to be going high. And as x goes to positive infinity, it's going to be going low. To find the y-intercept, you set x equals to 0. So that means we'd have negative 4 times 1 squared, which is negative 4. So the y-intercept is 0, negative 4. To write the function from a graph, you're going to look to see how many times it crosses. In this case, it crosses at negative 1, and then there's a bounce in the graph at 3. A bounce in the graph means that you're going to do that quantity squared. So the function is f of x is equal to x plus 1, just to the first power, and then x minus 3 squared. They're opposites of what they were inside the parentheses. And that's as far as you need to take that one. To do synthetic division, you take, so it tells you synthetic division, you take the initial values that are in the coefficient position. So 2, negative 5, 6, make sure there's no skips. If there was a skip, you would use a 0. And then you put the number on the outside, but we're not going to use a positive 2, we're going to use a negative 2 because it's with x. Same idea as like whenever you put something inside parentheses with an x, you flip the sign. Same is true if you're given x plus 2 as something to divide by. Drop the 2 down and then start cruising through synthetic division. 2 times negative 2 is negative 4, negative 5 and negative 4, negative 9, negative 9 times negative 2, 18. Add those two things together, you're going to get 24. That means the remainder is 24. And then we started out with an x squared. So that means the first variable in this case is going to be an x. So our solution is 2x to the first minus 9 with a remainder of 24. That remainder of 24 can be written as plus 24 over what you divided by. That's just the fancy way of writing the solution. So 35 is just a synthetic division problem, but it's kind of disguised. It says, given that this is a solution, find all the other zeros. So that means we need to do synthetic division, 1, 5, negative 2, negative 24, and then negative 4 is a solution. You don't switch it because it's not with an x, so you use it just as is. So we're going to drop this down, 1 times negative 4, 1 times negative 4, and then you would have gotten 0 in the end. That's great news. Now, with this remainder stuff, remember you start out with x cubed, so the next one's x squared. So this is x squared plus 1x minus 6. Now you can either try to factor this or you can use the quadratic formula. This one can be factored. So we figure out what numbers will multiply to give us negative 6, but add to give us x. And that's plus 3 and plus 2. To find all the solutions, that means you get all of the x values. And here they are, negative 4, negative 3, negative 2. If you wanted to do synthetic division instead of factoring, you could have. It doesn't matter. 36 is a multiply by the conjugate problem. So you start out with your original function, original expression, and you need to multiply by the conjugate. The conjugate is whatever was in the denominator with a negative symbol between them. This is so to get rid of i's in the denominator. So I'm going to multiply the bottom 2 out. If I multiply the bottom 2 out, I get 1 middle term, outside term, cancel, minus 9i squared. On top, top's not going to cancel, so we do have to be careful on this one. 2 times 1, 2 times negative 3i, negative 4i times 1, negative 4i times a negative 3i is a positive 12i squared. Okay, now we're going to simplify. So we get 2 minus 10i, 12i squared is equivalent to negative 1. So that becomes a multiplication. In the bottom, 1 minus 9i squared is equivalent to negative 1. So we would end up getting, I'm going to shorthand this is negative 12 and 2 combined to give me negative 10. And then on the bottom, 1 minus 9 times negative 1, well, that's really the same as adding 9. 1 plus 9 is 10, which means everything is divisible by 10. Negative 1 and I. I'm going to circle it so you can see it. I did this, and then I did this to get that solution. This is getting messy, sorry. So let's see. The last question is 37. 26, my bad. 7I to the 9th. All right, so earlier I said this piece about I squared being equivalent to negative 1. So that's something you should know, but in case you don't know, we came up with a rule. I1, negatives in the middle. So this is saying that if you have I to the first power, it's equal to I squared is equal to negative 1, I cubed is equal to negative I, and I to the fourth is equal to 1. This is the winner right here, I to the fourth. What we want to do is we want to break up every single exponent in terms of something that's divisible by 4. I need to make that a little bit bigger. The reason we need it to be divisible by 4 is because if it is, I to that power is going to be equal to 1. So 26. 26 can be broken into two numbers, 24 and 2, where this would be I to the 24th power times I to the second power, and then plus 7. I to the 9th can be broken into I to the 8th power times I to the first power. And then what's nice is that this and this are equal to 1. And it's because they're divisible by 4. So that means we have I squared plus 7I, but we know I squared is the same as negative 1. So you're really just looking for numbers that are divisible by 4, and then you break down the exponent using I1, negatives in the middle. These are simplification problems that you should be able to do with the power chart. First thing you're going to do on 38 is rewrite it. So it's saying square root of 49 cubed. So 7 cubed is 343. 16, the fourth root of 16 to the negative 1. Fourth root of 16 is 2. 2 to the negative 1 is 1/2. Negative 64 to the 2/3 power. That is a negative 1 times the cubic root of 64, then squared. That negative is not in parentheses. It is separate from the value. That means your answer is negative. The cubic root of 64 is 4. 4 squared is 16. Our final answer is going to be negative 16. 41, you're going to solve using your exponential log properties. So let's see, we know 8 and 4 are multiples of each other, but that doesn't matter. We know that they also have a common base. 2 is their common base. 2 squared is 4. 2 cubed is 8. Since we had another number inside the exponential line, you got to keep it. Then we take this expression and set it equal to each other. So that'd be 6x is equal to 2. Divide both sides by 6. X reduces down to 1/3. On 42, you're first going to check to see, can 9 be raised to a power to give us 27? And the answer is no. If it can't be raised to a power to give us 27, then that means we have to rewrite it. So 9, that's our base, raised to the exponent, x is equal to 27. Then you do the exact same thing you did in number 41. 3 squared times x, 27 is 3 cubed. Your expression is 2x equals 3. Divide both sides by 2. You get 3/2. This is one of the biggest elements, is knowing that you can switch it to exponential form. This other one is pretty fast and easy. Natural log e to the cubed power. This is a property that says anytime you have something in the exponential line and you've got a log with it, that exponent drops in front. Natural log of e is equal to 1, so 3 is the answer. So you could have probably done it quicker. It's always a good combo, having e and ln together. Identify the graph of the function. This is an exponential graph with a shift down 3. So it's not going to be this one, it's not going to be this one, those are up. So we have to know what an exponential line is. An exponential graph rises. B. To condense the logarithm, you have to use your properties. So it's actually what we just talked about. Anytime we have a piece with a logarithm, you usually drop down your exponent. Since the exponents already dropped down, in this case, we've got to flip them back to the top. So I'm going to do it underneath. Natural log of x to the 6th plus natural log of the quantity x plus 3 squared. In logarithms, every time you have an addition sign, that means that you can write it as a single log with multiplication taking place. So you just multiply those two pieces. All right, so 46 is a calculator question that's not going to be on your final exam, but it is something important for you guys to know how to do. It says to round to the nearest 3 decimals. To solve this, since you can't take 5 and 135 and put them in the same base, you have to take the log of both sides. I just take the natural log. You can take log, log, it's fine. You just have to write extra letters. It makes no difference. If you do the same operation on both sides, you're doing the same operation. When you take the natural log of both sides, your x is going to drop in front. You just have to make sure to do it to both sides. Then you get x by itself by dividing by natural log. And then all you have to do is type that into the calculator. Just make sure you do natural log of 135 and then divide that by natural log of 5. You get 3.048. So even though you didn't do this with a calculator, that is something you should be able to do. That's just understanding you take the log of both sides. Solve and round each answer to 3 decimal places as needed. I'm going to use the space below. So natural log of x is equal to 15. Again, same idea, getting log by itself. You could have raised it to the 6th power, but if we just want to solve, we can get x by itself, or natural log of x by itself, by dividing both sides by 6. And then natural log is really log base e of 15 over 6, which means once you have it in this log form, you can switch it to exponential form. Base raised to exponent equals answer, or argument. So that you would type into the calculator and you'd get 12.182. This is literally the e to the x button. It's a function on your calculator, not the letter e. Okay, so the exponential equation here shows that we have less than what we did originally, because this is a decay. This number is smaller than 1. And it's actually 6% smaller than 1. You can do that by finding 1 minus 9.4. You guys can do that mentally. And this is a decrease. Or you can say decay. If it was like 1.03, that would be a 3% increase. 49. If $4,000 is invested in a fund with an interest rate of 8%, we're going to go ahead and change that to 0.08. Compounded continuously, that means we're going to be using PERT. What is the amount of money in the account after 20 years? Time is equal to 20. All right, let's write our stuff. So we need the account balance with an initial value of 4,000, e raised to the rate of 0.08 times time, and this is plugged into the calculator. Type it in, you get $19,812.13. 50, somewhat of a logic question. An initial deposit of $3,000, that's principal, is made in a savings account compounded continuously. We're going to use PERT again. The balance will double, so double 3,000 is 6,000. That's the account, in time of 4 years. So 6,000 is equal to the principal amount of 3,000 e raised to the rate, which is what we are trying to find, times our years. So decoding that was half the battle. Divide both sides by 3,000. You get 2 is equal to e to the 4r. This is an exponential problem. The way that you solve an exponential problem is by taking the log of both sides. Natural log of 2 is equal to 4r times natural log of e, which means ln and e, that's just equal to 1. Those go away. Divide both sides by 4, and so your rate is calculated as natural log of 2 divided by 4. As a decimal, that is 173 as a rate. That's a lot. That's a big number. 17.3%. The number of bacteria present in the culture is given by the formula, so we're going to use the formula since it's given. Find the time required to the nearest tenth to have 3,000 bacteria present. 3,000 is equal to 1,000 e 0.276 t. Divide both sides by 1,000. 3 is equal to e to that power. All this is asking you to do really is to know that you take the log of both sides. If you take the log of both sides, you end up getting 0.276 t times natural log of e. Those go away. Divide by 0.276. That's the calculator portion. Type that in, and you get 3.980. Okay, 52. It says this person, Lindsay, bought a VW in 2003, so x is equal to 0. This is the starting point for 10,000, so that's our A value. In 2007, so that is 4 years later, the value was 5,488, so 4 is equal to 5,488. Use the model to find the exponential equation. Okay, so we know our A value is 10,000, b raised to the x. That's our step 1. Step 2 is to then take this x, plug it in here, and this y, plug it in here, and solve. So 588, 10,000, b to the 4th. So we're going to divide by 10,000. B to the 4th is equal to that expression. And since that is a very clear decimal, no random pieces that keep going on, that means we've got b to the 4th is there. We have to take the 4th root of that number to get our b value. So this is where the calculator piece really comes into play. And that b value would be 0.86. So the equation is y equals 10,000, 0.86 raised to the x power. So this is just understanding the equation itself. It is a calculator question, so you're not going to see anything like it, but you should be able to come up with an equation pretty easily, especially if one piece is given to you. All right, name the smallest positive angle that is coterminal. Coterminal means that they start and stop in the exact same location. That means you can add or subtract a rotation. Let's add 360 to this. So 360 minus 50 is 310. Determine which quadrant 750 lies in. Well, 750 is definitely over one rotation. And then it's going to be bigger than two rotations because 360 and 360 is 720. So what we do is take 750 and subtract away two rotations. You can do them individually if you want to, but it's good to know that double 360 is 720. That just leaves me with 30 degrees. Find the reference angle for 320. Okay, so you think 90, 180, 270, it's going to be somewhere in here. So 360 minus 320 is 40. Reference angle is always the distance back to the x-axis, this space right here. 6, 6 would be right here. 7, 6 would be here. This is the reference angle, pi over 6. Find the complement of something. Complement, remember we changed that into a 90. Complement means 90. So this would be pi halves minus pi fifths. So this is more about fraction work than anything else. Complement is 90, so just know that it's pi halves, subtracting the angle. So the common denominator between these two would be 10, so 5/10 minus, my brain just stopped there for a second, sorry. There wasn't a pause in the video, it was just my brain saying you've done too much math today. 2/10. I know y'all get that feeling, right? We all do. It's common. Math overload. 3 pi over 10, that's it. Convert to radians is that stoichiometry business. So pi, 130 degrees means that we need to multiply by a fraction that would get rid of the degrees. That's going to be 180 on the bottom. Pi is going to be left on top. Now, mathematically, your zeros don't matter. They divide out. So that's it. These questions are not going to be gotcha questions. They are going to be basic, do you know how to do one step, really? Convert to degrees. Negative 5/12 to convert. Pi has to be on the denominator so that they can cancel out. And then you can start simplifying. So this one takes a little bit of work. You can multiply it if you want to, but I would figure out what goes into 12 and 180, and 6 is the answer. So 12 divided by 6 is 2. 180 divided by 6 is 30. So that means I have negative 5 times 30 divided by 2, which is negative 75. The box was really crazy, but negative 75. Now here's the good stuff. Good old calculus. Here we are. These are the things that you've got to know for next semester. Cosine of 30. You should be able to do that in your sleep. Get your trig hand out. Cosine lives on the top. Fold 30 in. There are 3 digits, so square root of 3 over 2. Tangent of 210. We got to figure out what quadrant 210 is in. All students take calculus. Tangent of 210 is going to be somewhere in here. So the reference angle is going to be 210 minus 180. And so that leaves us with 30 degrees. Tangent of 30 degrees, fold your digit in. These are the same thing as radians. Fold your finger in, flip your hand over. You're going to get 1 over radical 3. This is not rationalized. To rationalize it, you may have these memorized. If you don't, you probably will if you've practiced enough. Multiply by radical 3 over 3. Next one, cosine of 45 degrees. Okay, 45 degrees, that's our reference angle, pi over 4. Fold in your digit. Cotangent is really just tangent upside down. Okay, so tangent of 45 degrees is square root of 2 over 2, square root of 2. Digits, digits, square root, 1. The reciprocal of 1 is 1. Don't overthink that. Okay, last section. These are drawing pictures. Once you have the picture drawn, then you can do the math. Cosine. Cosine is negative, tangent is positive. That means third quadrant. You have to find the missing side. The angle theta is right here. So cosine is the adjacent piece over 4. You have to figure out what the y value is right here. In other words, the opposite side. Notice it is going to be negative. So let's see, negative 3 squared plus the y value squared is equal to 4 squared. That's going to simplify to be b is equal to, or y is equal to the square root of 7, but it's negative because it's in the third quadrant and it's always negative. So negative. It says to find sine. So sine is that side we just found over the hypotenuse of 4. Same idea is true for the next one. Got to sketch it out, figure out what quadrant it's in. Cotangent is positive, cosine is positive. The only location where that's true is in quadrant number 1. Cotangent is equal to adjacent over opposite. So 1 over 3. You have to figure out the missing side. 1 squared plus 3 squared is equal to c squared. So c is equal to square root of 10. Which means if you want to find secant, secant is the square root of 10, the hypotenuse, over the adjacent side, which is 1. Square root of 10 over 1, square root of 10. Same thing, 65. Sine is positive, cosine is positive. That can only happen in quadrant 1. Hypotenuse is 3. The opposite side is square root of 5. So that means the square root of 5 squared plus your a value squared is equal to 3 squared. And it doesn't matter if you use b's, y's, whatever, it's just the missing piece. 5 plus a squared is equal to 9. A squared is equal to 4. A is equal to 2. And as for the tangent, tangent is that opposite side over adjacent side, so radical 5 over 2. Amplitude, 2. Period, 2 pi over b. b, 2 pi over 2, pi. Woohoo, we made it.